This is Robert Kleinberg speaking from Cambridge, Massachusetts. Always a pleasure to address the Methane Emissions Technology Alliance. The topic for today is navigating the methane impacts of the new climate legislation. This is a somewhat revised version of the talk that I first gave on August 25th, 2022. Today's date is August 28th. So let's proceed. The main topic of the talk today is the Inflation Reduction Act of 2022, Public Law 117-169. At the top of the page is the current link to the more or less final version of the law as enrolled. The Government Printing Office has not yet issued the final version, although no changes are expected. That should be coming out in a few weeks. The outline of the talk today is first the methane fee. I will be spending about half of this 35-minute talk talking about the methane fee. It's very complicated and interesting. Then there are shorter discussions of incentives for methane mitigation and monitoring, royalties on produced oil and gas, including methane emissions, carbon dioxide provisions, and finally, a page of takeaways. So the waste management charge, as it's formally known, or methane fee, as it's popularly known, is found in Section 60113 of the new law, and it's summarized by the small chart at the top. Basically, this methane fee comes into effect in 2024 at the rate of $900 per metric ton of methane emitted. And then escalates pretty rapidly in 2 years up to the terminal value of $1,500 per metric ton, which is coincident with the interagency working group social cost of methane, which is expected to be $1,500 per ton of methane. So that's the social cost of methane is basically what the United States government calculates is the global damage done by emitting an incremental ton of methane into the atmosphere. So, and it's a pretty high number. Just as a comparison, the International Energy Agency estimates that to reduce the US oil and gas methane emissions by 70%, would cost about a net of $176 per metric ton per year. And you'll see later where that number comes from. Now, the one thing about acts of Congress is that they are a bit like what a computer programmer would call spaghetti code, full of if, then, else statements, if you will. Certainly this latest Inflation Reduction Act is no exception to that rule. So there's plenty of examples, there's plenty of exemptions and loopholes and strange definitions that you need to understand in order to understand what this methane fee really is. And sort of the first and perhaps simplest exception to understand is that there is a upper limit of the amount of methane that can be emitted without paying the methane fee. And it's broken down by facility type. So, for example, for onshore and offshore gas production, you can emit up to 0.2% of gas sent to sale emitted as methane. For onshore and offshore oil production, where there's basically no gas sent for sale, you can emit as much as 10 metric tons of methane per million barrels of oil produced. For gathering and boosting, and for gas processing, and for liquefied natural gas operations, the exempt limit is 0.05, and for compression pipelines and storage, it's 0.11. Now, these numbers are pretty low, and not many companies can or probably have attained them. However, they are comparable to the goals set by the Oil and Gas Climate Initiative, the OGCI, which is basically a club of the largest international oil companies, mostly European. And several of those OGCI companies, claim to have already met these targets. So I think the Congress enacted this with the idea that this was by no means impossible. But we will see later that the reality of this could be somewhat different. So let's move on. Now, these exempt limits, what refer to, although this is not stated explicitly, but it's clear in context, that these exempt limits refer to basically subpart W filings from the oil companies of what their methane emissions are. Now, what does that mean? So subpart W basically is basically a spreadsheet exercise. It's the emission factor inventory method that was first established in the 1990s by the Environmental Protection Agency and the Gas Research Institute to sort of calculate what the expected methane emissions from normal operations is. And it is well known that these estimates are too low. And they're quite a bit larger when people actually go out and make measurements, and those measurements could be made by satellites, by aircraft, by mobile platforms driving around well sites, and so on. So just to give you an idea of the difference between the official U.S. government filings, for which, for example, the exempt limit is 0.2%, and what the reality is when you actually go out and make the measurement. So, for example, for onshore and offshore gas production, the nationwide U.S. estimate for methane emission from just the gas production part of the oil and gas industry is about 1.6% of dry gas production. And you can find that number by from Jeff Rutherford's paper of 2021, once you make corrections for the difference between gross withdrawals and dry gas production. So 1.6%, which is the actual U.S., what we believe is the actual U.S. methane emission intensity, is 8 times larger than the exempt limits. So this suggests that the methane fee is going to bite pretty hard into the industry, unless things change quite a bit. Now, looking at the onshore and offshore oil production exempt limits, that's 10 metric tons of methane per million barrels of oil. Well, those numbers are way, way short of contemporary estimates based on measurements. So for example, in 2020, Zhang et al., using data from the TROPOME satellite package, estimated that about 2,250 metric tons of methane were emitted per million barrels of oil produced from the Permian Basin. That's his numbers plus plus the EIA numbers coming out of the Permian Basin. So that is 225 times larger than the exempt limit. So again, there might be some unpleasant surprises when the invoices are sent to collect this methane fee. Now, just in the last few weeks, the Carbon Mapper Group has published a paper based on measurements in the near offshore Gulf of Mexico. So that counts as offshore oil production. And they find very much larger, 5,000 to 30,000 metric tons of methane per million barrels of oil produced. So again, 500 to 3,000 times larger than the exempt limit in the law. The Carbon Mapper Group also uses a very interesting way of sort of combining gas and oil production. They call it a joule loss rate. For those in the industry, that's sort of the same thing as a barrel of oil equivalent loss rate. If you calculate what 10 metric tons of methane per million barrels of oil is, that's a joule loss rate of 0.01%. The Carbon Mapper Group calculates loss rates of 3.9 to 18%. Those numbers aren't quite right, but for present purposes, we'll just use them. But still, many, many times, hundreds of times larger than the exempt limit. So again, it could be that owners and operators are going to have to pay very high fees if these fees are based on measurements. So this is going to come up as an important point, as you will see. So now this waste emission charge or methane fee is levied on a facility that reports emissions greater than 25,000 metric tons of carbon dioxide equivalent per year as per subpart W. Now, so first of all, 25,000 metric tons of carbon dioxide equivalent per year. Well, what does that mean in terms of methane? Well, assuming that most of the greenhouse gases are methane, which can be true in many production environments, that's equivalent to 1,000 metric tons of methane per year. You divide the 25,000 by a factor of 25, which is the 100-year global warming potential of methane, a number I do not particularly care for, but it's kind of US government standard. Okay, so 1,000 metric tons of methane per year is the same as 114 kilograms an hour. And I think, there's that people listening to this talk, many of them have made measurements and know that indeed there are sources out there that emit 114 kilograms an hour, but probably few or maybe even none that emit at that rate continuously for a year. When you look at 100 kilogram per hour sources, that might be intermittent, instantaneous, once in a while, occasionally for a while, but certainly not continuously for a year. So just on that basis, it looks like hardly anybody is going to hit that 25,000 metric ton per year carbon dioxide equivalent. However, that kind of depends on the definition of facility, and facility does not mean what you think it means. So let's look at that. So to understand what a facility is in terms of this law, we need to go back to subpart W and the definition of facility, which is in 40 CFR 98.238. And I'm just going to quote this directly from the law, from the regulation, where a person or entity owns or operates more than one well in a basin, then all onshore petroleum and natural gas production equipment associated with all wells that the person or entity owns or operates in the basin would be considered one facility. So a facility is not just a well site. It's not just a collection of wellheads on a site or a bunch of tanks in one place. It is everything you own in a basin. Now, what is a basin? Well, basins turn out to be pretty large, and it's the US government has adopted the AAPG basin map, which is shown on this slide. And you can see that basins are pretty large. For example, in the entire of Appalachia is one basin. The entire Permian is one basin. The Gulf Coast of Texas and Louisiana, stretching from the Eagle Ford all the way over to New Orleans, is one basin. That's the entire Gulf Coast of Texas and Louisiana. So these basins are big, and a lot of companies have many, many assets within that basin, which all would be added together and counted as one facility. So, whoa, there's going to be a lot of facilities that are going to wind up paying. But let's move on because we're not done yet. So one thing I sort of wanted to check on was, well, when you have these restrictions on basins and facilities, definitions and so on, what does that really mean in terms of what's actually reported? So I went back to the Greenhouse Gas Reporting Program, which is basically the fruit of the subpart W reports. And in 2020, it's pretty easy to figure that the Greenhouse Gas Reporting Program for the oil and gas industry amounts to 3.2 million tons of methane that year in 2020. Which was kind of a slow year as for oil and gas production, as you may know. So that is to be compared with the EPA inventory of greenhouse gas emissions and sinks that's reported to the Secretariat of the United Nations Framework Convention on Climate Change. EPA reported 8.2 million tons. So that tells us that subpart W is capturing about 40% of EPA estimate total oil and gas methane emissions. So about 60% of emissions is sort of getting underneath the screen. It's apparently small operators that don't have enough assets, even in these big basins, to make the 25,000 ton equivalent CO2 equivalent limit. But 40% of methane emissions are potentially subject to this methane fee. So, okay, interesting. But again, we are not done. There are still more loopholes and traps. So again, we have to understand very thoroughly subpart W. Now, as I said, as constituted today, subpart W data is emission factor data from spreadsheets with no operational measurements required. Now, I think a lot of you know that how these spreadsheets work. Basically, if you have a certain kind of valve that might leak methane, you count up the number of those valves, and then you multiply by the emission factor that the Environmental Protection Agency specifies. And then you go on to the next equipment type and the number and the emission factor of that and multiply it. And you add up all the results, and that gives you your emission factor inventory for all your assets. So again, using that system, you can sort of make sure that you don't exceed the 0.2% limit, say, by swapping out components that have large emission factors, large multipliers, with components that have small or no emission factors. And so that's how some people wind up saying that they have hit the 0.2% limit. But we people who are interested in measurements are a little bit suspicious of this whole spreadsheet business, because it has nothing to do with what's actually going on operationally in the field. However, in one of the most significant parts of this new Inflation Reduction Law is the following passage, which is in section 60113H. And I'm just going to quote this. Not later than 2 years after the date of this enactment, the date of enactment, which was August 16th, the administrator, that's the administrator of the EPA, shall revise the requirements of subpart W to ensure the reporting under such subpart and calculation of charges, waste emission charges, are based on empirical data. Now, empirical data means to me actual measurements. Now, that may be satellites, that may be aircraft, drive-arounds, whatever, but measurements made in the field. Now, in this law, there actually is no definition of what empirical data is. I'm a little worried that the people who interpret this law may not have the same interpretation of empirical data that I do, but I am hopeful that empirical data is what we think it is, which is actual measurement data. That would be pretty revolutionary all around, and particularly for this methane emission fee, as I think you are probably starting to see. But we are not done yet. Again, this is a bowl of spaghetti. There are so many exemptions, exclusions, definitions that you have to really keep track of all of them. And here are some very, very important exemptions. So one of them, 60113F5, I'm just going to read this. Charges shall not be imposed on emissions that exceed the waste emission threshold if such emissions are caused by unreasonable delay, as determined by the administrator of the EPA, in environmental permitting of gathering or transmission infrastructure necessary for offtake of increased volume as a result of methane emissions. Mitigation. So, this is interesting. This sounds like it might have been written by Joe Manchin, actually, because what it's saying here is that oil and gas companies only need to pay the methane fee if new natural gas pipelines are permitted. Now, Senator Manchin is very, very interested in the Mountain Valley Pipeline, which runs from West Virginia, crosses the Appalachian Trail, goes on to the eastern seaboard of the United States. What this says is, if there's an unreasonable delay in permitting, and believe me, there have been plenty of delays in permitting that transmission line, that means that the methane fee is voided. So there is going to be a lot of pressure on the federal agencies, such as the Federal Energy Regulatory Commission, to get these things permitted so that the methane fee then kicks in and people are fined for emitting too much methane into the air. So this is basically putting pressure on the environmental advocacy community. But in the next paragraph, there's another interesting passage, which I will read. Charges shall not be imposed upon determination by the administrator that I, methane emission standards and plans pursuant to the Clean Air Act have been approved and are in effect in all states. Keep that in mind. And II, compliance with the requirements described in Clause I, will result in equivalent or greater emission reductions as would be achieved by the proposed rule of November 15, 2021. Now, that rule referred to was the one that came out last year, late in the fall, by EPA. Basically, there was no regulatory language, so we don't actually know what they mean by this. But it suggested that there was going to be much stricter regulation of methane emissions from the oil and gas sector than had been heretofore the case. And so basically what this is saying is that as long as you have rules stricter than whatever those EPA regulations probably are going to be, then as long as you have those rules in place, then the oil and gas companies only have to pay until the EPA methane rules. Now, the interesting part is the phrase in effect in all states, because part of that 2021 notice of proposed rulemaking is that the rules were going to apply to existing facilities. Now, in the Clean Air Act, this is complicated. In the Clean Air Act, you can only regulate existing facilities if the states individually submit state implementation plans to the EPA. And as you might imagine, some states are more eager to do this than others. What this is saying is that oil and gas companies only pay the methane fee until these new EPA rules apply to all states. Now, that is a strong signal to all the states to get their state implementation plans in, because if they don't, these oil and gas companies are going to be paying the methane fee, and they will not want to pay that methane fee. So there's going to be tremendous pressure to get these methane rules done and out post haste. Okay, so that's it with the methane fee. As I said, a bit of a bowl of spaghetti there. There's a lot to unpack. And with all these crisscrossing exemptions and mandates and so on, it's kind of hard to tell where it's all going to come down. But I have a feeling that if there is a methane fee applied, it won't last for more than a year or two, if that, because there's a lot of very strong incentives for action here in this bill, which is not necessarily a bad thing. Okay, let's move on to oil and gas leasing on federal land. Now, this is something that excited a lot of distress in the environmental advocacy community, because what this law says is that if the federal government allows leases for renewable energy on federal land, they also have to allow comparable leases for oil and gas development on federal land. So this sounds like, okay, every time you put up a windmill, you got to have an oil well. Now, needless to say, a lot of people are pretty distressed by that prospect. However, you have to read these laws very, very closely. Now, what it says is that guarantees of new oil and gas lease offers have to be on the table, not leases, but lease offers. Now, in 2017, the Trump administration, eager to, make all kinds of, new oil and gas leases, put out a big lease offer. As it turned out, only 10% of federal land offered for oil and gas development was actually leased. So, because the law says federal government only has to offer, that means that you can build the windmill even if there is actually no lease made or oil well drilled. So very interesting. This rule may not turn out to be as negative as the environmental advocacy community might think it is. Now, moreover, the law actually makes federal leases kind of less attractive to the oil and gas companies. So, for example, the minimum royalty rate has been increased on August 16th from 12.5% to 16 2/3%, and that gets noticed among the accountants in the oil and among the oil companies. Moreover, royalties have to be paid on all gas produced on leased land, including gas that is vented or flared. This is new because heretofore, if you vented or flared gas from your federal leased well, you didn't have to pay royalty on it. Now you do at a rate of 16 2/3%. So what all this boils down to is that the federal oil and gas leases are even less attractive now than they were in 2017. So this may not turn out to be a big deal. So I think we can all sort of relax about that. There's a whole bunch of other stuff which I'm going to go into in less detail, although it's very pertinent to this audience. And that's incentives for methane monitoring and mitigation. So, for example, Section 60113 authorizes over $1.5 billion over the next 6 years for methane emission reduction for oil and natural gas systems, of which 700 million is directed to marginal conventional wells. Now, marginal conventional wells is sort of code word for small producers, like the mom and pops in West Texas who hate regulations, who don't even believe in climate change. Nonetheless, they are being given $700 million to start believing. The balance of it goes into a wide variety of other programs of sort of various relevance to this audience. One provision, which is in Section 60105E, is quite relevant to this audience, which is $20 million over 10 years for monitoring methane in research, development, planning, and control programs. So that says it has the words monitoring methane in it. So this is a pure measurement appropriation, and it's obviously a relatively small number, but still, worth tracking. The law also lays out substantial grants for various programs to reduce greenhouse gas emissions, including methane, in the agricultural sector. So agriculture is not forgotten in this law. Okay, so I was talking about sort of $1.5 billion. Well, what does that buy you? So to answer that question, I consulted the International Energy Agency, methane abatement cost curves, which are published every year for a wide variety of countries. The US compilation is really the only one that's kind of believable. The others less believable, but I think the US number, at least is a good place to start. And what IEA says is that the US oil and gas sector, in their estimation, emits something like 13.8 million tons of methane per year. Now, What this curve represents is on the horizontal axis is the cumulative abatement in kilotons per methane per year from 0 up to above 9,000 kilotons. And the vertical axis is the net cost of abatement. So this is how much it costs to fix the problem, but deducted by the methane that now you can sell into the natural gas market. And that's all annualized, and the units are dollars per million BTU per year. A million BTU is 1,000 cubic feet of gas. So what IEA says is that about 2.5 million tons, or 18% of total methane emissions, can be remediated at negative net cost. In other words, you get more back from selling the gas than it costs you to fix the problem. And now 18% is a lot lower than the numbers that you commonly see quoted by various groups when they're quoting the IEA, that they usually use global numbers. The 18% seems reasonable to me because it's well known the oil and gas industry is not fond of leaving money on the table. And so I could well believe that a lot of the problems that they think they can make money on, they are making money on, and they fixed the leaks. And you could see that way more than half of that 2.5 million tons is really very marginal. It's almost zero, so maybe not worth fixing. As far as the 7,000 million tons over here, that's about 50% of the total. And this is all the emissions that will have a net cost to fix. In other words, you don't get as much back from selling the gas as it costs you to fix the problems. And it is extremely unsurprising that little has been done here, because no company, especially no oil company, wants to invest money in something that is not going to give them a positive return on the bottom line. So there you go. 7 million tons of technically feasible emissions not yet done, which could be done, but you have to have some sort of incentive, either regulatory incentive or market-based incentive, but something, or else people just won't do it. Okay, so let's kind of look at where these numbers come from. So the IEA, and again, I would only really trust this for the US, has these pretty big spreadsheets, and they divide up these methane emission sources in a very, very granular fashion. So you have, for example, unconventional oil blowdown capture, onshore conventional oil blowdown capture, onshore pump replacement, unconventional gas pump replacement, et cetera, et cetera. And the top, about 85 lines altogether. So 85 different sort of individual tech segments of places that emit methane. Now, in this top part of the chart that I've reproduced here, these are all things that actually give you a return on your investment. So the cost in US dollars per kiloton of methane avoided is negative. That means you're making money from it. The bottom part, which is actually more extensive, are the abatement mitigations that will have a net cost to the operator. Therefore, they are not so happy to do it. So if you take all those 85 rows, add up the cumulative cost, negative at the top, positive at the bottom, you wind up with a net output, net cost of $1.7 billion to remediate 9.6 million tons of methane per year. So, okay, well, $1.7 billion to fix 70%, basically 70% of the problem. The last 30%, IEA says, not technically feasible. Okay, I'll take the word for it. Okay, so let's see what this means. So again, we're abating 9.6 million tons of the 13.8 total, the 70%. annualized net cost of $1.7 billion. That comes out to $176 per ton. Now, that was the number I cited on slide 1. So you see that it's actually, I mean, compared to the social cost of carbon, it's much, much cheaper to fix the problem than absorb that methane fine. And kind of that is the point, isn't it? This all seems like a real, the methane fee, if it's ever imposed, because of all this twisty-turny bowl of spaghetti, we don't know, but if it is ever imposed, certainly people would rather spend $176 a ton than pay $1,500 a ton for, per methane ton of methane emitted. Now, will $1.7 billion break the bank of U.S. oil and gas companies? No. Basically, the annual average revenue for U.S. oil and gas operators was something like $157 billion. So that's quite a bit more than 1.7 billion. And expected U.S. oil and gas capital expenditures over the next several years is expected to be in excess of 100 billion. So again, we're asking that you take your 100 billion CapEx budget and add maybe 1% to it, 2% to it, in order to clean up this methane problem. And the US government is tripping in about a sixth of that on an annual basis over the next 6 years. So not that the feds are paying for everything, but they are helping out. And that's kind of grease the skids here and get these companies moving to cleaning up stuff. Okay, so now kind of coming toward the end here, I just want to talk about the CO2 world for a minute, because this is another really interesting aspect of this problem. So basically, carbon capture and sequestration, very interesting because, although oil and gas consumption is going down in the US and Europe and other industrialized countries, still the transition to zero fossil fuel is going to be very lengthy. And in the meantime, we need to be doing as much as possible to mitigate this carbon dioxide problem, going into the atmosphere and causing global warming. Now, turns out, and this has been well known in the industry for quite a while, more than a decade, that it costs somewhere between $60 and $110 per ton of carbon dioxide to capture carbon dioxide, compress it, and store it underground in a safe manner where it won't come out. And the company I used to work for, in fact, was in the business of doing that and was quite competent in doing that. Now, however, the problem is that the $60 to $100 is a cost of disposal for which the operating company gets nothing back. There's no profit to be made here. So guess what? No one's doing it, or very few are doing it, because it's a money loser. So why would, you can't ask the garbage collectors to pick up your garbage and not pay the bill. That's kind of really what it boils down to. So back 2008, there was the Energy Improvement and Extension Act, which provided a tax credit of $20 per metric ton of what the U.S. government calls carbon oxide. There's a story there. And basically with a slow increase, up to 2020. But you can see that the $20 a ton tax credit is not going to convince anybody to do anything. And indeed, it really didn't. There was government programs paid for by the government that were pilot projects, but nothing that was commercial. So along comes the Bipartisan Budget Act of 2018, and they decide, okay, we got to do better. So they put the tax credit, it's called 45Q, tax credit on a faster ramp, terminating in $50 per metric ton of carbon oxide. Still not enough. Still, it's below break even, and again, not much interest in this particular provision of the tax code. I mean, there was another part of the tax code which gave you tax credits for using carbon dioxide for enhanced oil recovery, which the oil companies were doing anyway, and they took advantage of that. But as far as taking carbon dioxide, actually putting it underground and storing it without using it to produce more oil, it was a non-starter. So one of the interesting features of this Inflation Reduction Act is finally a realistic tax credit for carbon capture and sequestration, $85 a ton starting now. And that should be more than enough to pay for a lot of carbon capture and sequestration. So now we're going to find out whether the promise of CCS has anything, can hold water. I mean, all the numbers say that it should work. Moreover, there's another provision in the new law which gives direct air capture, which is a much more expensive proposition. They get $180 tax credit per ton of carbon dioxide sequestered. And that's kind of at the lower limit of what the direct air capture people say it would cost them to use that technique. So now we're going to be sort of testing their truthfulness, the truthfulness of their claims. And well, let's hope it works. So anyway, but at least it's a good try. So this is really a positive part of this new bill. Okay, so takeaways. Again, 1.57 billion for oil and gas. Methane emission reduction programs, that's almost a year's worth of abatement. So that's kind of like real money. 1.5 billion spread out over a variety of oil and gas program types, of which half go to small producers. That's a pretty big treat for them. 20 million over 10 years is specifically directed to methane emission monitoring R&D. So it's a relatively small amount of money, but it's one that people listening to this talk might be able to take advantage of, along with whatever you can get from the 1.5 billion. Substantial funds for reduction of agricultural methane emissions. That's starting to look interesting. And I didn't go into detail on that, but I invite you to study the law if you're interested. There's a very, very important subpart W empirical data mandate starting in 2024. This has not yet been defined by the agencies. We hope that it means what we think it means, which is real measurement of operating assets. If that's true, it will be revolutionary. Methane fee is used as a leverage to encourage a variety of activities, including natural gas pipeline permitting, improved EPA rules, and definitely prompt state implementation plan submissions. So no one should be a laggard on this one. Now, there's a very, very important thing that's not explicitly stated, but which is very important, which is this law sends a message to the Supreme Court that Congress is directing action on greenhouse gas remediation. Now, this was a big issue in a Supreme Court decision that came down earlier this year called West Virginia versus EPA, where the Supreme Court ruled that Congress had not spoken on whether coal-burning power plants could be shut down, and therefore the agencies had no right to take action that would have that effect. That was a huge increase in the power of the Supreme Court to basically manage how federal regulations work. Well, now Congress is coming in and saying, oh, yes, we are now directing action on greenhouse gas remediation. And the greenhouse gases are emitted, carbon dioxide, methane, nitrous oxide, and all the rest, over and over again. So there is no mistaking what the direction here to the Supreme Court is. Bottom line, though, there's no requirement to actually reduce emissions, but there is certainly a lot of push, both incentives and some punishment, to kind of ensure that it happens. So I think this is a good law. A lot of it remains to be sorted out, and a lot of it's pretty complicated. as I think you've seen. But there we have it. And I'm fairly optimistic. So with that, I'd like to end. Again, if you have further questions or discussion, contact me. My email address is shown in red here on this slide. And thank you very much for your attention.